All right, so section 5.1 is on angles. We already talked about how the axes break the plane up into 4 different quadrants. 1, 2, 3, 4. Don't mind that. We know that the initial side always starts on the x-axis, specifically the positive side of the x-axis. And we had started talking about what the degrees of each of these axes actually represent. So since we start over here, that's our 0 degrees, and we take a right angle to get us up to the y-axis, which is 90 degrees. Okay, another 90 degrees, another right angle brings us to 180 degrees. Another right angle brings us to 270, and that again brings us back around to 360 degrees. Okay, remember that there is another way to represent the measure of an angle. Okay, so we're generally used to seeing it measured in degrees, but we can also measure it in something called radians. It's just another way to define the circumference of a circle, or specifically the different measures of the angles. So our radians, we're going to do in green, but they follow kind of the same pattern. We start at 0 radians. And usually you know it's radians because there's no degree symbol with it. You can literally write the word radians if you want after that, but for now, I'm just going to put a 0. We'll come back to 90 degrees in a second. 180 degrees, right? So half of a circle. That is equal to pi radians, right? Pi 3.14. So going halfway around the circle, that angle is a measure of 3.14 radians, or pi. Okay? Since 90 degrees is halfway between 0 and pi, 90 degrees is the same thing as half of pi, or pi divided by 2. Okay? So each quadrant, when we're talking about radians, represents a length of pi over 2. So we've got pi over 2, then another pi over 2, which brings us to pi. Then another pi over 2, right? So we've got 1, 2, 3 pi over 2s. Okay, 3 pi over 2. And then another one, which is 4 pi over 2, or that simply reduces to 2 pi. And just like with the degrees, we can keep going around and around in the circle. Now, these angles that happen to fall on each of the ends of our axis, they actually have a very special name. They are called quadrantal angles. Okay. Quadrantal angles, they're any angle where the terminal side, the end, where it stops, falls on an axis. So all of these angles that we have written up here so far, they are all quadrantal angles. It's not really something you're going to be tested on, but you could see the word mentioned, especially when you start working on your MyMathLab homework. Okay, quadrantal angles, angles where their terminal side falls on one of the axes. So that kind of gives us the breakdown of what the measures of angles can be. But now we're going to talk specifically about the different types of angles. And there are specifically 5 different kinds of angles. And they really go kind of by the quadrants that they can fall in. So the first kind of angle is an acute angle. And basically that's anything in the first quadrant. Right? So it could be in quadrant 1. And that means it has to be between 0, theta, remember that's our symbol for an angle, between 0 and 90 degrees. So that's our first kind. Anything in the first quadrant. Once we get to our first quadrantal angle, that is specifically called a right angle. It doesn't fall in a quadrant, it's literally between 2 quadrants. And in that case, theta is equal to exactly 90 degrees, or pi over 2, right, if we want to talk about radians as opposed to degrees. Once we get past our right angle, anything in the second quadrant, where the terminal side falls in the second quadrant, so between 90 and 180, is called an obtuse angle, right? So that is in quadrant 2, and that is between 90 and 180 degrees. Our next quadrantal angle also has a very special name, right? That is called a straight angle. For obvious reasons, it forms a straight line. Okay. So again, not in a quadrant because it falls right on the axis, but this is when theta is equal to 180 degrees, or pi radians. Okay. The last one, which is not one that a lot of people are familiar with, anything that goes beyond 180 degrees, so something that falls in either quadrant 3 or quadrant 4, is called a reflex angle, right? And that could be, again, quadrant 3 or 4. And that is just any angle that is greater than 180 degrees. Okay? In all of these ranges, they're referring to where the terminal side of that angle is. So we know this was the initial side. If our terminal side falls over here in quadrant 2, that means we have an obtuse angle. Okay? So you can kind of see the different types of angles. When we get into triangles, at least to start, we're going to focus on right angles specifically and acute angles, things that are less than 90 degrees. Okay. All right, so with all of these angles, we've briefly mentioned the fact that there are 2 different ways to measure how big an angle is. Okay. One of those ways is degrees, and the other is radians. And we're going to use both of them kind of interchangeably throughout the unit, right? So it will be important for you to kind of get used to how to convert between the 2 different measures. So in order to do this, it really is based on the fact that 180 degrees is equal to pi radians. Okay? This relationship is very important because what it allows us to do is to make a fraction, something like pi over 180, which is actually equal to the reciprocal of that, 180 over pi. Since these values are equal to each other, since 180 degrees is the same thing as pi radians, these fractions are equal to 1. And what that lets us do is to take a particular angle, whatever it happens to be, and multiply it by one of these 2 fractions. Because we can multiply anything by 1 and it doesn't change the value of that number. So by multiplying by one of these 2 fractions, what we're doing is canceling out the unit we have and turning it into the unit that we want. All right, so then it's just a matter of figuring out which of the 2 fractions you should be using. When we move from degrees into radians, we're starting with something that is already being measured in a unit of degrees. When we multiply by one of these 2 fractions, we need the degrees to cancel each other out, which means degrees has to be in the denominator. So when we are converting from degrees to radians, we multiply whatever our angle is by the fraction pi over 180 degrees. When we're going the other way, so if we're starting with radians and we want to turn it into degrees, it's just the opposite. We're going to take our radians and we're going to multiply it by 180 over pi. And what that lets us do is cancel out the radians that we already have and turn it into degrees. All right, so we're going to look at a few examples of how to do this exactly. We're going to start by going from degrees to radians. All right, and our first example is going to be 45 degrees. Okay, so this is an angle. It is an acute angle. It's less than 90 degrees, which means it falls in the first quadrant. And if I want to change from degrees to radians, I'm going to multiply by pi over 180. When I do that, it's going to give me a fraction, 45 pi over 180. Remember, this is 45 over 1. Multiply straight across. And with any of these radian measures, you're always going to want to simplify it, reduce it to lowest terms. These both have a common factor of 45. 45 goes into each of those numbers. So when we reduce this, it actually reduces to, let me change this, just pi over 4. 45 goes into itself once. 45 goes into 180 4 times. Right, so 45 degrees is exactly the same thing as pi over 4 radians. Okay. All right, let's take a look at another example. We can start with 150 degrees, and same process. We're going to take that and multiply it by pi over 180. Which gives us 150 pi over 180. And then you can go ahead and work on simplifying that. It should reduce down to 5 pi over 6. 30 goes into both of those numbers. 30 into 50 is 5. 30 into 180 is 6. And again, that's in radians. We can also talk about negative angles. Something like negative 225. It's just as easy to take this and convert it into radians as we did the positive angles. Same exact process. Multiply it together. Okay, you get negative 225 pi over 180. And again, that is going to simplify. It's going to give us negative 5 pi over 4. As our radians. Okay. If you are having trouble simplifying the fractions, there is a way on your calculator to reduce fractions for you using usually the fraction button or the ABC button. If you're not sure how to use this, right, and you want some help, make sure you ask, okay, and we can take a look at it together. All right, so those are just converting some of those angles from degrees into radians. And those all gave us some nice answers in terms of pi. And usually that's how radians are going to be written. They're going to have a pi involved in them somehow. But not always. Sometimes they may ask you to just find the decimal approximation for an angle. Okay, so we could have something like 18 degrees, and they just want to know what is that in radians, right? To the nearest, we'll do 2 decimal places. Process doesn't change. It's still multiplying by pi over 180. It's just this time when you actually try to evaluate this, you're going to type this whole thing into the calculator. 18 times pi, you should all have a button that has pi on it, divided by 180 degrees. And when you do that, it gives you a decimal answer, which is approximately 0.31, and again, that's in radians. We could do the same thing with 157 degrees. Right, multiplied by pi over 180. So you should go ahead and try that in your calculator. 157 times pi, and again, use the pi button. Don't just use 3.14. And that answer divided by 180. When you do that, you should end up with 2.74 as your radians. And you can see both of these examples, they don't have pi in them, right? So we've actually converted pi into its numeric value as opposed to leaving our answer in terms of pi. Okay, so that's going from degrees into radians. Now we're going to look at a few examples where we go the other direction. So we're going to start with radians, and the first one we're going to look at is pi over 2. Pi over 2 is our radians, and we want to change that from radians into degrees. since our radians are what we're starting with, we're going to multiply this by 180 over pi. I know this is going backwards, just trying to keep the order the same. When we multiply this, again, we go straight across. So it's going to give us 180 pi over 2 pi. Well, the pi's will cancel, and 180 divided by 2 is 90 degrees. Okay, so pi over 2 in radians is the same thing as 90 degrees, and that's one of our quadrantal angles. Really, the only difference is that we are using the reciprocal of what we did for the first few examples, and that's to help us kind of cancel out this value of pi. If we look at another example, something like 2 pi over 3, okay, turning it into degrees, multiplied by 180 over pi. You can either cancel the things out at the beginning if you'd like. Our pi's will cancel. And this is going to give us then 360 over 3. And that happens to be equal to 120 degrees. If you're using the note sheets that are on UV Learns with this, you can go ahead and try those other two. See what you get as your angles that are on there, 7 pi over 6 and negative 3 pi. A lot of times when we start with radians, like I mentioned before, it's going to have the pi in it already, but sometimes it won't. We could have something that is literally just 2 radians. No pi's, okay? Just the number 2. We still convert it the same way. We still multiply it by 180 over pi. The biggest difference is we're going to have 360 over pi, and this we're just going to type in the calculator. 360 divided by pi, divided by 3.14, whatever that happens to be. So 2 radians on a circle, or as an angle, is the same thing as 114.6 degrees. And hopefully that should make sense to you. Pi, which is 180 degrees, is 3.14 radians. This is less than 3.14. This is less than 180 degrees. Okay, so that's being able to convert between the two different measures of angles. Now we're going to take a look at how to actually draw these angles. We're sketching them. So, sketching angles in standard position. Is what we're going to take a look at now. And standard position just means that your initial side is starting on that x-axis and then we're moving in the counterclockwise, in the backwards direction. And we'll look at a few different examples of these. I'm just going to put this over here as a little reminder what our quadrantal angles were. And we'll start with the degrees. Those will be our first few examples. So when we're trying to sketch something like 60 degrees, really what you're asking yourself is what quadrant does that fall into? 60 degrees is between 0 and 90, which means it's going to be in quadrant 1. Right, so if we put our axes up there, 60 degrees is 2/3 of the way between quadrant 1. Okay, and this is our theta. Usually you want to indicate where theta is, right, by putting that line in there, just to show that it's the positive angle as opposed to the other side, going the other direction. Let's take a look at another one. 135 degrees. Again, we ask ourselves, which quadrant is that going to fall into? Well, it's bigger than 90, but it's less than 180, so it's got to be in quadrant 2. Right, and it happens to be exactly halfway, right in the middle of quadrant 2. Right, so this is our angle, 135 degrees. Now, when we were converting between degrees and radians, we mentioned the fact that there could be negative angles that we're working with. So you could, instead of having 135, you could have the angle negative 135. And really what that means is that instead of moving counterclockwise around our axes, we're actually moving in the opposite direction. We're going backwards or clockwise. We still start at exactly the same spot. Okay, the positive x-axis is still our initial side, but we're moving in the other direction. So we go backwards 90 degrees, but we don't go quite to 180 degrees. So negative 135 is actually going to be in quadrant 3. Right, and that is our theta. So that's graphing them angles that are given to you in degrees. Let's take a look at a couple of angles that are given to us in radians, because again, those are going to be a little bit more unfamiliar for people, a little more difficult to figure out. So if we erase these, just on our little cheat sheet over here, this is 0 radians. Remember, this is pi over 2, this is pi, and this is 3 pi over 2. And here, your comfortability with fractions is really going to help you with being able to work in radians. Okay, so as our first example, pi over 6. One of the things I'd really like you to be able to do is to take something like pi over 6 and figure out which quadrant it should fall into without converting it. Some of you may need to rely on changing that into a degree first, but let's take a look at how we would do this otherwise. Pi over 6 is a pretty small number. It's definitely not a whole pi. It's only 1/6 of a pi, which means it's less than pi. It's also less than pi over 2, right? It's not half of a pi. It's only 1/6 of a pi, and that means it's going to fall in quadrant 1. It's going to be down here. There's our theta. It's a very small number. And if you turn that into degrees, you'd find out that it is 30 degrees, which we know is in quadrant 1. Let's take a look at something like 7 pi over 4. 7 pi over 4. If we just focus on the fraction part of that, 7 over 4. This is 1.75. Okay, so we've got really another way to think of these. This is half of pi, 0.5 pi. This is 1 pi. This is 1.5 pi. And this is 2 pi. Well, 1.75 pi is going to fall between 1.5 pi and 2 pi. It's going to be right in the middle of that. So that's one way to think about it, changing your fraction into a decimal. It's going to be over here, 7 pi over 4, right, as our theta. You can also think about it, 4 goes into 7 more than once, but not twice. So it's got to be bigger than pi, but less than 2 pi. And it's actually bigger than 1.5 pi's. But again, you could go ahead and convert that. This is 315 degrees, which would ultimately tell you that it's going to fall in quadrant 4. All right, let's look at one last example. I'm going to do negative 5 pi over 4. So again, we can talk about going in the opposite direction. 5 over 4, right, if we were to divide that, is 1.25. Right, so we're going backwards, more than half of a pi, more than a full pi. We've got 1 additional quarter of a pi. So that actually happens to be our theta. In terms of how accurate your pictures need to be for something like a quiz or a test, I'm really just looking to make sure you have it in the correct quadrant. Right, so you don't necessarily need to know that this is exactly halfway between 90 and 180 degrees. Okay, as long as you have it in the correct quadrant, you'll be fine. All right, so that's being able to take an angle, no matter what measure it's in, and rewrite it, okay, or draw it, excuse me, in standard position. And again, this last angle here, this is negative 225 degrees. The last thing then that we're going to talk about for section 5.1 is one specific type of angle, or a relationship between two angles. So let's take a look at something like negative 60 degrees as our angle. If we were going to sketch this, we know that it's negative, which means we're going clockwise, we're going backwards around the circle, and it's going to fall in quadrant 4 because we're not going 90 degrees. So this is negative 60 degrees. Okay, we're going backwards by 60. This angle can be represented as a positive angle, okay, that goes in the other direction. If we think about what this green angle would be in the positive direction, hopefully you can see that this took up 60 degrees of the 360. So this big angle here, the green angle, is 300 degrees. Okay, and we can say that negative 60 degrees is coterminal with 300 degrees. They both end at exactly the same spot. And that's the type of angles that we're talking about here. So, coterminal angles. And those are angles with the same terminal side. So we can see that negative 60 degrees has a terminal side right here in quadrant 4, and 300 actually has the same exact terminal side, right? So they both end in the same place. But usually when we're talking about coterminal angles, we're not going to take the time to graph them. We're going to find them algebraically. Okay. Let's look at another quick example with the graph, and then we'll talk about how to do it without drawing it. So we've mentioned that it's possible to have angles that are actually larger than 360 degrees. Okay, we could have something like 395 degrees as an angle. And if we were going to graph that, right, or sketch what that angle looks like, we go around the circle one complete time, but then we've only gone 360 degrees so far. We still have to go an additional amount to reach 395. Specifically, we have to go another 35 degrees. Right, so that gives us an angle that is 395 degrees. It falls in the first quadrant. Well, the angle that's coterminal with that is just this regular piece right here, which we know is 35 degrees. It's 395 minus that first revolution of 360, which leaves us with 35 degrees. And that's an important thing to keep in mind about coterminal angles. When we're looking for coterminal angles, they have to be positive and they have to be less than 360 degrees. Or 2 pi, remember if we're talking about radians. So when we're given an angle and we're asked to find an angle that's coterminal with it, we are looking for a positive angle that is less than 360 degrees. Okay, that's the criteria that we're going to use to find them. All right, so let's talk about how we might do this without using a picture. We've got 395 degrees. We know that that is bigger than 360. It goes around the circle more than once. So if we want to find out how much is left over, what angle is going to be coterminal with it, all we need to do is take that number and subtract 360 degrees. And that gives us 35 degrees as our coterminal angle. Right, let's take a look at another example. So if we talk about 750 degrees, that's, again, obviously bigger than 360. So we can take away one complete revolution. Okay, if we go around the circle one whole time, we're going to end up right where we started. When we subtract that, we get 390 degrees. This is a positive number, so we meet criteria 1, but it is not less than 360 yet. So we actually have to go around the circle again. Take away another 360 degrees, and that leaves us with 30, which is positive and less than 360. So if we were going to graph 750, we go around the circle once, there's 360. We were on the circle again. There's 720. And then we still got 30 degrees left in our angle to reach the terminal side. Let's look at one last example with degrees. And that, of course, is going to be when you have a negative number. So negative 150 degrees is actually not bigger than 360. And if we were to use the same strategy to take this and subtract 360 degrees from that, we're actually going to get an even bigger negative number, which is neither positive or smaller than 360 degrees. Right? So we actually don't want to do that with negative numbers. If you think back to the picture that we did, we have negative 150 degrees is going to be here. Right? This is 150 degrees. Think about how much of the circle is left over. We've used up 150 degrees out of the whole circle, out of 360. Right? So we can actually take this and instead of subtracting, we're going to add 360 degrees. We're going to take this and we're going to swing it around one whole time, right? And that's going to leave us with 210 degrees. Positive, less than 360, this is our coterminal angle. Okay. So you're either adding or subtracting 360, and it really just depends on the sign of the angle you're starting with. Right? If it's a positive number, usually you're going to subtract 360. If it's negative, you're going to add 360. All right, so that's how we do it with degrees. Let's take a look at just a few examples with radians. All right, so one radian angle could have a measure that's 19 pi over 6. Right? We know that with our degrees, we subtracted 360 degrees from that. But that's not going to do us much good here because this is radians and this is degrees, and we can't subtract them unless they're the same. So instead of using 360, we're going to use our radian equivalent, which is 2 pi. We're going to subtract 2 pi from that. I'm going to go ahead and erase this just so that I have some more room to work. This is a fraction, which means we need to make this a fraction, 2 pi over 1. And when we subtract fractions, we have to have common denominators. Right? This has a denominator of 6, so we're going to make this fraction also have a denominator of 6. And the way we do that is to multiply top and bottom by the same number. Okay, so this is actually going to turn into 19 pi over 6 minus 12 pi over 6. Okay, and when we subtract those two numbers, we get our answer, which is 7 pi over 6. Okay. This number is less than 2 pi. 6 goes into 7 once, but it definitely doesn't go in twice. So this is our coterminal angle for 19 pi over 6. Okay. There's actually another way that you can approach this. If you're not comfortable with the whole dealing with fractions and converting it into having a common denominator, we can take a step to actually change this into degrees. Right? And remember how we change radians into degrees. We take our angle. We know we have to multiply it by something that has pi and 180 degrees in it. Since pi is in our numerator, we want it to be in the denominator of our fraction. The pi's will cancel. This will cancel. And when you do this, you should get 570 degrees, I think. You should go ahead and verify that first, though. 570 degrees. Then we can find the coterminal angle of this, right? So that goes back to subtracting 360 degrees from it, which leaves us with 210. Then we can change this back into radians. Right? And the way we do that is by multiplying by this reciprocal. So we've got 210 degrees times pi over 180, which equals 210 pi over 180, which equals 7 pi over 6. So it's up to you which method you want to take. This is obviously a little bit longer just because there's a couple of extra steps with converting. But a lot of people don't like working with fractions or radians in general. So you can either subtract by 2 pi or you can go through the process of changing one into the other. Okay. But if your angle starts off as radians, your coterminal angle also needs to be in radians. So you can't just find that 210 is coterminal with it, right? We need to know what the radian equivalent of 210 degrees is. And we're going to look at just 2 other examples with a fraction so you have something to follow, and that'll be it for this section. Okay, so let's take a look at 23 pi over 5. Okay. One way that you can see if it's greater than 2 pi or less than 2 pi is to take your denominator and divide it into the numerator. 5 goes into 23 4 times with a little bit left over. So this is definitely bigger than 4 pi. Right, so that means we need to convert it, which means we need to subtract 2 pi, which we can make 2 pi over 1. Our common denominator is 5, right? So times 5 times 5. This becomes 23 pi over 5 minus 10 pi over 5. When I subtract those two, I get 13 pi over 5. And again, you want to say, okay, is this less than 2 pi? 5 goes into 13 more than twice. It goes in twice with some left over, so it's going to be bigger than 2. So we're not done yet. We need to subtract another 2 pi or another 10 pi over 5, which leaves us with a final answer of 3 pi over 5. So 23 pi over 5 is coterminal with 3 pi over 5. And again, if you want to convert this, change it into degrees, find the coterminal angle, change it back into radians. Again, you're more than welcome to do that. All right, let's look at one last example with a negative angle. So we're going to look at negative pi over 50. And just like with the degrees, when we had a negative angle, we added instead of subtracting. We're going to do that here too. We're going to add 2 pi, right? 2 pi over 1. Our denominator is 50, so we need to multiply this by 50 over 50, which gives us negative pi over 50 plus 100 pi over 50. Remember, this is negative 1 pi. Negative 1 plus 100 is 99 pi over 50. 50 goes into 99 not quite 2 times, so this is actually less than 2. This is our final coterminal angle. Right? And if we think about what those would look like on a picture, negative pi over 50 is a very small angle that happens to be in quadrant 4. 99 pi over 50 is everything else. They both end, again, in exactly the same spot. Okay. There are one additional sheet, 2 extra topics on the note sheets that deal with arc length. You can go ahead and skip those. We're not going to cover those this semester. Just the stuff on the angles, and that should be enough to get you through your homework.